This one might look like it's already in standard form a little bit, but there needs to be a digit in the ones column, not just a placeholder. So it's 7 times 10. Now what's that going to be? What's the power of 1? Well, there's 1 0, including the one in this ones column, so it's -1. Okay, and then this is going to be 8.01 times 10, 1, 2, 3 to the -3. So I should have done those more as examples, really, because I think once you've seen a few of these examples, you can understand a little bit more clearly what on earth I was on about up here. Okay, so look, it's 3.89, 4.12, 6.9208, 7, 8.01. Okay, it's always going to be between 1 and 9 in the ones column. Okay, might have freed up that task for you. Okay, the other way is, sorry, the other part is just going back the other way, so we may as well cover that now. So we've done something like 10 to the 6 equals. So what about 3 times 10 to the 6 equals? Okay, well 10 to the 6 means 10 times 10 times 10 times 6 times, but we can think it's got 6 zeros. Which is 1 million. So this is going to be much the same, but we've got a 3 here. So we're then going to do 1, 2, 3, 4, 5, 6. Okay, that's probably okay. But what about when we've got some decimal points here? 1.48, again, times 10 to the 6. So straight off, because this is going to be a big number, it's going to be 148. We're going to have to shift that decimal. And then what I would think about, or the way I would approach it, is think I need 6 digits after the first digit, but there's already 2 here. 1, 2, 3, 4, 5, 6. So we're going to have to go 1, 2, 3, 4, and then we've got 5, 6. Okay, so it should be, as you can probably imagine, 1.48 million. If this is 3 million and this is 1 million, 3 million, this is 1.48 million. Let's put some commas in there to check. Hey presto, 1.48 million. Oh, just before I continue, should have drawn your attention to these numbers. Then are really easy to compare, because to begin with we can ignore this bit 3.89, 4.12, no 6 point, and just look at the tens. 10 squared is a lot smaller than 10 to the power 5. 10 to the power 4 is a bit smaller than 10 to the power 5 and a bit bigger than 10 squared. 10 to the -1 is smaller, much smaller, and 10 to the power -3 is smaller again. So if you were asked to put these 5 numbers into the standard form answers in order, be really quick. This is the biggest, next biggest, next biggest, next biggest, next biggest. Okay, so really useful when we're comparing. It's things like comparing the size of stars and distances between planets and that kind of thing, or for looking at the size of atoms and electrons and that kind of thing. So it is either super massive stuff or super tiny stuff. So just do a couple more on the positive side. 9.2 times 10 to the 4 and 2.901 times 10 to the 7. Can you ever get those? So this one's going to be 9, 2, and then we've got 4 zeros, but one's already kind of there, or one place value, one digit is already there. So it's, oops, I stopped a bit early there, didn't I? We need 4, so it is 92,000. And this one we're going to put 2901, and then we need 7 digits in total after the 2, but we've already got 3. 1, 2, 3, 4. So there's 1, 2, 3, 4 digits after this one. So that is going to be hopefully 29 million. Nice. So you'll get used to a few shortcuts. 10 to the 3 is thousands. 10 to the 6 is millions. We may not get there, but 10 to the 9 is billions. And also 10 to the 2 is hundreds. So what I mean by that is if you see 5.6 whatever times 10 to the 9, okay, well that's 5 billion. 5 billion and some other stuff. If it was 5.61 times 10 to the 6, it'd be 5 million. 3 would be 5,000. And then at least you can work out, well, if I'm in sort of 4 or 5, then I'm somewhere between thousands and millions, to give you an idea of the size. So now, yes, could you pause the video and have a go at task number 121, please? Task 121, just pause the video. Okay, for the next task, I think you can probably already do it, but we are still converting from ordinary numbers, we call it, into standard form. Now we did, I think you'll be hopefully quite confident at a number bigger than 0, 59217 equals something times 10 to the something. Always, this is the standard format. It is a standard format and it's always going to be the same. Digit point something times 10 to the whatever. But we might not yet be too groovy with small numbers. So what goes up here? Well, it's 5.9217. Okay, and then we think, right, how many, what do we need, what the power of 10 is? It's the number of digits here, so 1, 2, 3, 4. This is 5.9217 times 10 to the 4, lovely jubbly. Now, this one, the first bit hopefully is okay, it's going to be 3.92. But then working out the power of this, the power of 10. So you can just go 1, 2, 3. It's minus 3. Just remember to include. I worry about this method. I only started using this to count the zeros a couple of years ago, and now my class loved it, but just be careful you don't trip up. The way I used to do it, probably still do it, is to think, right, for each digit up here, so there's 4, 1, 2, 3, 4. For each one, you move one column in terms of place value. Now we're supposed to teach you to move the digits, not the decimal point, but it's so much easier when pointing, as you will do on your exam paper and in your book. So much easier to use a decimal, but it's actually the digits that are moving. But anyway, oops. So I go 1, 2, 3. Okay. Because this is divided by a tenth, divided by a hundredth, or well, timesing, sorry, divided by 10, divided by 100, divided by 1,000, or timesing by a tenth, timesing by a hundredth, timesing by 1,000. So it's minus 3. Whichever way works for you, but you just need some nice clear notes. I don't think they get any harder than that. Let's have a look at the last one. No harder than that, but we'll do one more. 0.000503024. So we're just going to pick up that first digit that's not 0, the 5, make everything else after the decimal. These placeholders are essential, so don't remove them. 03024, and then we can work out the power of the 10. So as I said, my method, the way I do it is 1, 2, 3, 4, 5. I don't claim that that's necessarily easier, but I think it's perhaps a bit better for understanding, because that's what you're doing. Times 10 to the power of -1, times 10 to the power of -2, times 10 to the power of -3, etc. So I'd like you to do task 122, please. Pause the video and do that. Sorry about that. So the next one is just going the other way. Do I think that's easier? I don't know. 3 times 10 to the 8. I will bang on about that one just because I think it's cool fact. 3 times 10 to the 8 meters per second. So we know it's going to be 3. Let's focus on, because it's often this is a decimal. So let's remind ourselves there are going to be 8 digits after the 3. 1, 2, 3, 4, 5, 6, 7, 8. In this example, they're all going to be zeros. 4, 5, 6, 7, 8. So it should be 300 million. Good. I won't do numbers quite so big, perhaps 4.02 times 10 to the 3. Okay, so first of all, write these digits out. Just because I happen to know that the decimal point will fall at least after the 2. But perhaps a good way to focus is, if you remember, I said about 10 to the 3, you get used to 10 to the 3 being thousands. So that means I can tell that this is going to be 4,000 and stuff. But anyway, if we write 402, we can always put the decimal point in afterwards. So the 3, sorry, so that's where that came from. Let's do a different color. So this is 3. So we're going to need 1, 2, 3 digits after the 4. So we need another 0. So it's 4,000. Okay. Let's flip over to teeny weeny. 3.1 times 10 to the minus 2. Okay. Just write those digits. 3, 1. And then okay. So 2 ways of doing it, probably more. As I said about moving the decimal place, the decimal point. So go 1, 2. So when I've moved 1 place and put the decimal point here, but I've got to move again. So when I do that and put the decimal point here, I need a placeholder there. Otherwise the decimal point it doesn't work. So that is 0.031. I didn't mean to change the question, that doesn't look right. So 3.1 times 10 to the negative 2 is 0.031. Now, of course, if you remember, the 2 is 2 zeros, including this one. I'll keep banging on about including that one because that's my concern. But so quite a nice way just to check your answer if you use the number there. And 5.0039 times 10 to the minus, the smaller one now. So first of all, write out these digits. I leave deliberately a little bit of space just in case I need to put the decimal in anywhere. But of course, these are teeny numbers, so it's actually probably easier than the big numbers. So 5, I'm going to need, again, there's several ways of doing it. I'm going to need 7 zeros before the 5. Or I'm going to go 1, and then 2, 3, 4, 5, 6. So I'm going to have 6 zeros between the 5 and the decimal point. Again, I've got to move it. Whoopsie daisies. You can me like that, or you. Pressing the button on the pen. So 0.1, 2, 3, 4, 5, 6, 7. So that is where the decimal is. So that is where the, that's horrible, isn't it? Sorry about that. Good. There you go. So 0.6 noughts and then 50039. So including the 0 at in the ones column, we should have 7 zeros. 1, 2, 3, 4, 5, 6, 7. Cool. And that's it. So kind of converting these very small numbers back into a normal number is kind of harder, but then in a way it's kind of easier, because these will all be zeros. When you convert it into a normal number, these will be zeros because they're just placeholders. Because we're saying rather than this being 5 in the ones column, this is 5 in the 100,000ths or something. So I would now like you to do task 1, 2, 3.